I'm a dangerous.
Okay.
Yeah.
All right.
Think we're good? You want me to go?
Yep, go ahead.
Okay. Hi, I'm Arnie Gunderson from Fairwinds, and today I'm at the San Onofre nuclear plant that's in the background. San Onofre is presently shut down. It has steam generator leaks, and I wanted to give this demonstration today to talk about what it is exactly that a steam generator does and how they can leak. Well, this blue thing around me represents the key component inside the steam generator, and it's called the tube sheet. It's 2 feet thick, solid steel, and 13 feet wide. So that's just about the shape and size of what I'm standing inside of. Now this would be a solid piece of steel before it's fabricated. Weighs about 100 tons, it's enormous. Now, first thing they do is they drill holes into this tube sheet. They drill 9,700 holes on this side and 9,700 holes on this side. What happens then is when they put the steam generator together, hot water comes from the nuclear reactor, and that's symbolized by this orange pipe. So hot water would go through that. It's actually 32 inches in diameter, and 250,000 gallons every minute comes in. It comes in the bottom and goes up through those holes that are drilled in the steam generator tube sheet into the steam generator tubes. So hot radioactive water is running up inside these tubes that crosses over, cools, I'll pick it up and it crosses over. So hot radioactive water comes in from the bottom up through these tubes, crosses over, and comes down on this side. Now where I'm standing is not the radioactive side. I'm standing on the non-radioactive side. Radioactive water is inside these, and hot steam and hot water is where I'm standing. Now, if you notice, these things are shaped like U's. That's why it's called a U-tube steam generator. The pipes come in, cross over, and come back in the shape of a U. Now, we've modeled up 3 tubes here. In fact, there would be 9,700 tubes on this side, and each one would cross over into 9,700 tubes on this side. What's happening inside San Onofre now is that San Onofre made a design decision.
Okay, let me fix that. Tape, makeup.
There you go.
One knee here. Should we tape that back and over it? Yeah.
Okay.
Yeah, I got one back here.
Ah, I'm falling apart. Just like the generator, right?
Maybe we could get a job at San Onofre.
Oh, there you go. I hope they're using more than duct tape. You know? We'll see. Okay, are we ready? Okay. We're good?
Sunny.
There's a helicopter behind me
yes,
somewhere.
It's the Marines. Hovering just on the other side of the plant all day.
Okay. Now, when San Onofre decided to rebuild their steam generators, they made a design change And I believe that it's that design change that's causing the tubes to fail inside. Right where I'm standing, right in the middle of this tube sheet, down below was a massive pillar. It was called a stay cylinder. San Onofre decided to get rid of that massive pillar down below to cram more tubes into the steam generator. Instead of 9,300, they got 9,700 tubes. By removing the place right below me, more tubes meant they could get more heat out and more electricity out. But it also changed the flow inside the nuclear steam generator. What's happening in San Onofre now is that these tubes are vibrating. And they're colliding with the pipes, with the pieces of metal that are designed to keep them separated. The vibrating tubes are hitting each other and hitting the support plates, and in the process it's denting the tubes. Some of the dents have gotten so bad that the pipe wall is completely worn away and the tube has to be plugged. Now, the solution to this problem, as far as San Onofre is concerned, is to plug these tubes. They would send people down below and put plugs in the bottom of these tubes. That would keep the radioactive water out of these tubes. But it doesn't stop the vibration, because on the side I'm on, you've got non-radioactive water turning to non-radioactive steam up above. So this U-tube is actually much taller than I am. It would be up 20 feet, and above me would be high pressure steam, but it would be non-radioactive. As long as these tubes don't leak, no radiation gets out. Let's go again. Are they Southern Cal guys? Huh? So they're checking us out, huh? They probably took a camera picture.
Okay.
Okay. Okay. So the new steam generators with their crammed tubes are banging into each other and banging into the supports. Again, there's all sorts of space in my design, but remember there's 9,700 tubes inside those domes behind me in each of the steam generators. They're colliding with these plates and denting the tubes. The dented tubes are then leaking, and the space that I'm in, which would be non-radioactive, is becoming radioactive. That's what caused the unit to shut down in January. Radioactive steam from inside this pipe broke through and entered the non-radioactive side of the piping. Now, the problem at San Onofre was stopped because they shut down quickly. They were releasing 1/2 gallon a minute of radioactive steam, but inside this pipe, it's 2,200 pounds per square inch. Where I'm standing, it's 1,000 pounds per square inch. So there's a lot of pressure difference causing that steam to shoot out. And in a very short time, if they don't shut down, that steam actually cuts these tubes and can cause a cascading problem, where one tube crashes into the next tube, crashes into the next tube. That's the most serious accident that could happen in the event of a tube failure at San Onofre, and it would require an evacuation of the people nearby. It would also challenge the emergency core cooling system, because the emergency core cooling system has to make up for the water that's leaving the nuclear reactor and entering the non-radioactive areas. So the solution at San Onofre is not to plug the tube. Plugging the tube stops the leaks, but it doesn't stop the vibration. The solution at San Onofre is to go back to the old design, to put that stay cylinder back in place so the vibration goes away. And at that point, they'll have steam generators that last and are safe for the people in the people that live near this plant. Thank you. Did I miss anything? Do you want me? Should I redo anything? We can cut and paste.
I didn't hear it all. I thought the part about the tubes whipping around like a garden hose.
Yeah.
You said that last night. That was pretty dramatic.
Okay, I'll add that then.
I think too,
Yeah.
if you took a short piece of it and put it closer to it, because people, they're seeing it all far apart.
Oh, sure.
Yeah.
Give me a. Yeah, that's a good idea.
There might
Yeah.
be a couple of straps.
That's a really good idea. Okay.
And that can represent it.
Yeah, yeah.
And tell me, do you know if it's banging between here, or is it only banging here as well?
The tubes are actually hitting each other in between, and they're banging where they're supported with these support structures. They're both. Yeah, yeah.
And then I didn't listen to everything you were saying, but the amount of time it takes from going to pinhole to where it could be very serious, that's just hours or days? Or
That's a day. Yeah, less than a day. Yeah. Well, let's shoot this, and then we'll do that.
We're
Okay.
that close to. I mean,
Yeah.
people don't realize how close we might have been to a really serious problem.
Yeah, yeah.
So, the pinhole, when the pinhole bursts, it bursts into another weak point on the other pipe, right?
It can. Yeah.
It would be
Yeah.
because
Yeah. Because the pinhole will be where the next pipe over is also weak. Right.
Right. So I think
Right.
that's the point to say that both pipes are weak also.
Okay. Now, in fact, we put these this far apart so we could show the U-tube shape of the tubes. In fact, they're incredibly close together. And there's 250,000 gallons of water squirting between these tubes every minute. 9,700 tubes on this side, 9,700 tubes on the other side, and all of them have about 1/4 of an inch of gap of water between them. What's happened is that the tubes are vibrating and hitting each other. And where they're hitting each other, they're wearing thin. At San Onofre, the one that broke was because it was hitting another tube, or it was hitting one of these tube support sheets. When that happens, not just one tube is damaged, but all the surrounding tubes are damaged as well. Now, when San Onofre shut down on January 31st, they had a pinhole leak in this pipe. That pinhole leak could have become a much bigger leak in the period of less than a day, because there's a 1,000-pound pressure difference, and it would have cut this metal like a knife over a period of about a day. Think about a garden hose whipping around on your lawn. A garden hose has 60 pounds of pressure in it. This pipe had 2,200 pounds of pressure in it. So if this one were to whip around, it would hit all the surrounding pipes, causing a cascading problem. In that event, you have a serious accident that would challenge the emergency core cooling systems and likely cause an evacuation as well. Anything else? Is this our camera guy walking down the beach? Any news now?
Oh, right on.
You and your wife and the baby.
Fantastic.
And they talk about your wife's comments about the brain cancers and stuff like that. Yeah, it's up today. Yeah. Cool.
Do you need this prop anymore?
I don't know. Let's just set it inside here.
Yeah, you got a whole nother crew coming.
Yeah. It could be a stay cylinder down below. And that was structurally there. But they wanted to cram more tubes in, so they eliminated that and put another 400 tubes in this center section. And what we're trying to show is that by cramming more tubes in, they change the flow pattern, and they're causing these tubes to flutter and hit each other. So now, however you want to shoot that, and I'll shoot it in shorter segments, obviously.
I know it's a little back.
Well,